Okay, see Lindelof videos. Third video today on verifying trig identities. You guys should stop sending me these things. They drive me nuts. But okay, here we go. Keeping in mind, when you're asked to verify a trigonometric identity, two things should be true. One, if you're asked to verify an identity, then your professor should be saying to you that it is true and that it can be proven. They shouldn't be saying verify it if it's not true. So you have to go kind of on the assumption that it is true. Having said that, remember that you can only manipulate one side, and it's almost always a left-hand proof. Having said that, we're only allowed to manipulate the left-hand side of this equation, and the right-hand side we must just carry along with us. So what I'm going to do first is I'm going to start working on this. There's more than one way to do this. There's loads of ways to do this. So as long as your trig is good, it will work out. So here I go. I'm going to distribute this sign into all this, and that will give me sine theta plus sine theta times cotangent squared theta is cosine squared theta, isn't it? Over sine squared theta. Okay? Remember, I'm just going to bring this bit down here, so I'm just going to bring this here. So it's down here. Now, if you look, I'm going to leave this sine theta here. But look, I have a factor, this is times, I have a factor of sine theta here, and two factors of sine theta here. Remember that sine squared theta means sine theta times sine theta, right? That's what this 2 right here, that's what it means. It's this thing times itself. So I'm going to end up with cosine squared theta over sine theta equals cosecant theta. This was not squared, right? Okay, here I'm just going to try to make these, I'm going to add these two pieces together, so I need to multiply this piece by sine theta over sine theta, and if you can see why, because the second fraction has a denominator of sine theta, so I need the same thing, so I'm going to multiply by sine theta over sine theta. If I get sine theta times sine theta, we get sine squared theta plus cosine squared theta. Remember, now we have like denominators. We don't add denominators. We just carry them over. So over sine theta, right, is equal to cosecant theta. This looks like hell, but it's about to come together really well. If you think about the first Pythagorean identity, the first Pythagorean identity says that sine squared theta plus cosine squared theta is equal to 1. So I'm going to use a replacement value. Sine squared theta plus cosine squared theta is 1. So replace that numerator here. Leave the denominator here. Sine 1 over sine theta is equal to is equal to cosecant theta. This is true, but we have to give a reason that this is true. And this is true because we know that cosecant theta is the reciprocal of sine theta. So this is true by the reciprocal property. So we can just say reciprocal ID. Your professor does want to see you identify what rule you used to establish your proof. So one more real quick. All right, let's try this. So here's the last one I want to do today, which is 1 minus sine squared theta over sine squared theta is equal to cotan squared theta. Wow. All right. What are we going to do with this mess here? Oh, I can see it. So look, I'm thinking of the first Pythagorean identity, and the first Pythagorean identity says that sine squared theta plus cosine squared theta is equal to 1. If I manipulate that, if I just subtract sine squared theta from both sides, I get cosine squared theta equals 1 minus sine squared theta. This bit right here is this one, isn't it? So I can replace 1 minus sine squared theta with cosine squared theta. This is my solidus, same one. So sine squared theta at the bottom, sine squared theta at the bottom is equal to cotan squared theta. Again, we're done. Why are we done? Because this is the reciprocal identity. So this is also a recip. I'm just going to put recip ID, and we've accomplished our bit. All right. I hope this is really helpful. I want to encourage you and tell you that this can be done, and you feel brilliant when you actually get it done. It takes a little while, and you have to keep working and working and working. If you have not memorized those 8 or so fundamental trigonometric identities, you can't do this. There's nothing wrong with you. You just have to memorize those rules first. So please go back to your book and memorize those IDs, and then you'll start seeing that you can plug them in for stuff. All right? So hope this is helpful. If you have any questions or comments, let me know. And please, if you haven't already subscribed, please do. Thanks.